Hello, and welcome to the ELEKTRA training video series. This video will cover an overview of how to define and apply frequency lists, attenuation factors, transducer factors, and limit lines. If you're following along from the connecting devices video, I'm continuing from where we left off. To begin, let's cover frequency lists. In ELEKTRA, click Tables in the left sidebar and navigate to Frequency List. Your screen is likely blank, which means at this point we can create a frequency list ourselves by clicking the plus sign, which is the Create Frequency List button in the lower left corner, or we can import a list by clicking the CSV icon, which is the Import Frequency List button. First, let's import a list. Click the CSV icon and navigate to the folder where your list is saved. Select the file and then click Open. This presents you with a table import pop-up where you can choose how to import your data. For this particular list, the main column to pay attention to is frequency. In our case, our list is in megahertz, so we will use the drop-down to select the appropriate frequency units. You'll notice that there's nothing to select in the comment column. For a frequency list, this column should be filled with all zeros because you're only going to use the first column for frequency. Once you are finished, click Apply to preview what your list will look like. If something looks wrong, you can click Original to go back and make changes. Otherwise, click Import. At this point, your frequency list has been created. If you were creating a new list instead of importing, you would be at this screen entering data manually. One thing you can change at this stage is whether the data was collected in log or linear format. Do that by using these drop-down boxes. At this point, you need to save the list to the ELEKTRA database. Click the Save icon, give your frequency list an appropriate name, and attach any user tags you might want to include. You can use existing tags from the drop-down, or you can create your own custom tag. Finally, click Save. Moving on, if you're going to do an attenuation table, you would follow a very similar process to what we just did for a frequency list. By selecting Attenuation in the left sidebar, you are presented with the plus sign to add a new attenuation factor, or you can again perform a CSV import. As a quick note, when you're creating an attenuation table, a second column is now activated and will always be in dB whether creating a new table or importing one. Now let's work with transducer factors. In the left sidebar, select Transducer Correction. You are again presented with the ability to create a new transducer correction or import one. Similar to the attenuation tables, a second column is required, but this time it is for correction level. You can choose the applicable units using this drop-down. The correction level unit needs to match the limit line from the standard that you're testing to. In this example, we're going to do a radiated measurement, so our correction level unit is dB microvolts per meter. The measurement unit defaults to dB microvolts, and this is determined by the instrument you are measuring with. If using a receiver or spectrum analyzer, you are usually measuring in dB microvolts. With a power meter, however, you might be measuring in dBm. If you're entering a factor for a current probe, you would use dB microamps for the correction level and dB microvolts for the measurement unit. When entering in the factor, type in the inverse polarity. This accounts for the factor in dB ohms. So as an example, if your factor reads negative 10 dB ohms, you should type in 10 dB microamps in ELEKTRA in the correction level column. Lastly, let's work with limit lines. In the left sidebar, select Limit Lines. You are again presented with the ability to create a new limit line or import one. If you create a new limit line by clicking the plus icon in the lower left, you are presented with a pop-up to select the type of limit line you are making. If you choose Cal, you're making a limit line for a calibration routine, for example, for a cable calibration. If you choose EMI, you're making a limit line for an emissions measurement. Lastly, if you choose EMS, you're making a limit line for susceptibility measurement. In this example, we'll choose EMI, and you will notice that we have 5 total columns that we can fill out. Choose your applicable units, detectors, and interpolation options, and fill in your data similar to the factors we've already discussed during this video. If you have an EMC standard that uses multiple limit lines with different detectors, you can enter them here individually in separate columns rather than creating an entirely new limit line for every combination thereof. Previously, in other test softwares, a separate limit line had to be created for each detector. This concludes the training video on defining and applying factors in ELEKTRA. If you're following along, the next video will cover hardware setup.